Today we are going to be adding literal equations into our notebooks. That is page 36. So when you add these in, okay, you're going to have your literal equations title page on the left and then the rest of the example problems on the right. So pause it if you need to take time to get those added in. When we are talking about literal equations, we are going to be looking at equations that will have more than one variable in the equation. Okay, so now instead of just solving for a variable, we're going to have lots of variables happening at the same time. Okay, you're going to be asked to solve for a specific variable. All the steps and properties that we've learned from solving regular equations are still going to work for literal equations. So you don't need to learn anything new. You just have to get adjusted to the idea that it won't be numbers, it's going to be letters. And sometimes that's the hardest part for my students to get past, right? There's actually less computation, there's less math because there aren't numbers to combine. Okay, and the majority of the time we are just going to be using our basic inverse operations, okay, to simplify the equation and then get it to its specific variable. Okay, so for example, if we look at number one has a minus b equals c, and it's asking us to solve this for a. Okay, so if you're the type of person who looks at this and goes, oh my gosh, the only thing that I can see happening right here is the letters, that overwhelms me. Pretend for a moment that they aren't all letters. Pretend that this says a minus 2 equals 10. Well, what would you do if you wanted to get a by itself, right? You would add the 2. So it's no different over here. We want to undo the subtraction with addition. Okay, so we're going to be adding b to both sides of the equation. And just like those 2's would cancel out, so will the b's. And where this is actually less work is because we can't add c plus b, so that just leaves us with an answer of c plus b. Okay, if we look at number 2, same idea, we are going to solve this for m. Again, if you can't get past the idea that that's that many variables, well, just try and think about it if it was a number there, right? What operation happens when we don't see an operation at all? Well, that's multiplication. How do we undo multiplication? We undo multiplication with division. And so since I need to get m by itself, it's not the one moving, so I'm moving the x. My x's will cancel, and I will get m equals c times d all over x. Okay, number 3, we are solving for b. So our objective is to get b by itself. Now, one of the hardest things for my students to understand on this is that this mn is kind of attached together as one thing because it's not with the b. So a similar idea to if I had a times b plus 4 times 5, right? Typically, I would take that 4 times 5 and turn it into a 20 and then treat that 20 as one number. I just can't simplify that anymore, but I'm still treating that as one number. Okay, so if I want to get that b by itself, right, we always undo any addition or subtraction first, which we have addition. So I'm going to undo adding mn by subtracting mn. Again, less math. Yes, I'm left with an ab. That's cd minus mn. I can't do anything with. Okay, then our next step is going to be to undo multiplication, right? If we want to get b by itself, we have to get rid of that a. And we undo multiplication when we don't see an operation at all. We know it's multiplication. We undo that with division. Now, remember, we've said this before. Multiplication and division are things that go all the way through. So we have to make sure this fraction bar comes all the way over. Okay, it would also be acceptable that if we were looking at this problem, I'm going to actually write it underneath here, and we had AB equals CD minus MN, we could divide by the A in all 3 places, and that would mathematically represent the same thing. So whether we're putting that one big long fraction bar, or whether we're putting it with all terms, that is the same thing. And we will write that in different ways based on what's most beneficial to us for a given problem, which we're going to see coming up. Okay, so our A's cancel. So our final answer is CD minus MN all over A. Or it would also be acceptable if you had B equals CD over A minus MN over A. Number 4, we are going to solve this for Y. Okay, so now we do have one number at play. I don't know if that makes you feel any better or not. Okay, but if we want to get this Y by itself, again, we're focusing on the side with the Y, just like we do with any equation. That X is attached in the addition and subtraction world, which means we always look in front of it. The X is positive, and we undo a positive X with a negative X. So we are subtracting X from both sides. Now, if you remember from way back when, the fancy beloved formula of Y equals MX plus B, okay, it is more traditionally written when we are in this situation, because we're solving for Y, that we're going to put that X in front of that 15. I'm not going to count you wrong. There's no requirement that says you need to do that. Okay, but you're just going to see that coming up more and more. So it's fine if you cancel this out and you say negative Y equals 15 minus X. Just don't be surprised if you also see a situation where that's written as a negative X plus 15. Okay, then we have to undo multiplication. There's still this negative 1 sitting here. Now, we could just write that big long fraction bar over here. Okay, but it is going to be to our benefit to write this divided by in every single place whenever there is something that we can simplify, right? And negative 1 is definitely something we can simplify with. 15 divided by negative 1 is a negative 15. Okay, and this X has a negative 1 in front of it. A negative 1 divided by negative 1 is a positive. Okay, and so our final answer would be Y equals negative 15 plus X. Equally, don't be surprised if you see places that have the answer as Y equals X minus 15, right? The X is what's positive. The 15 is what is negative. Okay. 8X plus 4Y equals 12 if we are solving for Y. Just like we talked about with that M and N, that 8X is all together in one chunk. So we're going to move that all together and subtract 8X from each side. 12 minus 8X, those are not like terms, so we cannot combine them. 12 minus 8X is just 12 minus 8X. If I have 12 apples and I give away $8, those have nothing to do with each other, so they cannot go together. Then we will undo our multiplication with division, and here's a case that it's going to be helpful to write it in each place because we can simplify. Right? 12 divided by 4 is 3. Negative 8 divided by 4 is a negative 2. And you might also see that as a negative 2x plus 3. Either of those options would be correct. Number 6, this is asking us to solve for L. So this is actually a perimeter formula. Okay, if we want to solve this for L, again, we're undoing any addition and subtraction first. So I'm undoing adding 2W by subtracting 2W. So that will give me a P minus 2W equals 2L. I'm undoing my multiplication with division. Okay, again, right here, that 2 is going to be able to simplify. So it's going to be my benefit to write it in all 3 places. So P over 2 I can't do anything with, but that 2 over 2 I can reduce to a 1. You can write that 1 in there, but you don't have to. So L equals P over 2 minus W. P over 2 minus W equals L. Any of those options are fine. Okay, on our next one, we are going to solve for R. So 2 pi R. Right? I don't know if we remember what that is, but this is when we're dealing with the circle. Okay, so if we want to solve this for R, here's where students forget that pi isn't a letter. Pi, well, I mean, right? Pi is the 3.14 never-ending number. So this has 2 times pi times r. There's all multiplication holding that together. So we can just divide by this in one big chunk. So I can just divide by 2 pi and divide by 2 pi. So those cancel out. And I'll go r equals x over 2 pi. Here, next one, we want to solve for b. Now, we could. This is multiplication and this is multiplication. So absolutely positively, just like we did over here, we could divide this all at once by 1/2 h. Oops, I got a little carried away with my bar there. And so we'd have b equals a over 1/2 h. The problem is that we don't write a fraction within a fraction. That's a big no-no, which means we still have some simplifying to do. Okay, so what number is sitting in front of that a? 1. Right, so what this really says is 1 divided by 1/2. And if you need your calculator to help you do that, you can, but 1 divided by 1/2 is 2. So we'll get 2a over h. Number 9, we are solving for y. So if we want to get y by itself, we're going to move this big chunk over here. So we're going to undo a negative 5x by a positive 5x. So we'll get a 7y equals 11 plus 5x. These are not like terms. We cannot put them together. Okay, we'll undo multiplication with division. Now, it's not really to our benefit here to reduce anything. So we have the option that we could write it in all 3 places. Or we could just leave it as one big fraction bar as well. It's not really doing anything for us. I am always you're going to see me written it in 2 separate places just because long term, when we do slope-intercept form, right, that beloved y equals mx plus b, it's going to help us out a little bit extra to already have that and have seen that. And then our last one here, solving for b. This is definitely our longest. Okay, so if we want to solve for b, again, we're going through those same inverse operations. So we know with a large fraction, we're moving that denominator first. So we undo dividing by z by multiplying by z. We don't know what r times z is, so we're just going to leave it as rz. We undo any addition or subtraction. We don't know what rz minus m is, so we just leave it as that. And we undo multiplication with division. So right over here, this is all a bunch of letters. Yes, I can write those each over a. You'd be totally fine, I would count you correct. It's not doing anything for us either way because this literally doesn't mean a whole lot. And so our final answer would be b equals rz minus m all over a.